So I've started experimenting with how to work with my video card directly from C++ or C++ programs that I build and run within FreeDOS. Trying not to go through the BIOS or interrupt calls to get to drawing pixels and rectangles and shapes and things like that. So my goal is to write to the video card memory directly from a C++ program. And here I'm going to go ahead and turn on my system. And for this video, I'm running the processor at 10 megahertz, the bus at 20. And I'm going to change into a folder REHSD that I've just been placing some stuff in and run Screensaver. And here you can see it's a very, very basic type of a screensaver, if you want to call it that. I'm just drawing randomly placed, randomly sized, randomly colored rectangles around the screen, or in this case I think they're all squares, but drawing those. And as I'm doing this, I am writing directly to the video card memory, and I'm also directly accessing and modifying a register on the video card. And I'm not doing that through BIOS calls. There are still some things I am doing in BIOS calls, but all of the register access and the memory for the video card now I'm doing directly. And I can escape out of the program. It takes me back to a command prompt. I can rerun it just to kind of see how random the randomness really is. So then the question is, how am I starting to do this? And I thought I would walk through that quickly and just show how I am getting directly to my video card memory from a C++ program in FreeDOS. So over here on this screen, this is my Visual Studio. The first thing I had to do is update how I'm building. And we're going to work in a file called main.cpp, and when I build that, it's going to make a main.exe, and I'm going to turn around and just rename it to screensv.exe. And that's what I ultimately then copy onto a CF card, put into my FreeDOS 286 system, and run it like you see in this other clip. But one thing I had to change on this is the memory model. So previously I was using this small memory model. That's what this -ms is. And I had to change that to either MC or ML. They both seem to work. And I think that's a compact and a large, if I remember correctly. But basically saying I need to get to more than just 16-bit addresses from C++. I want to get to a 32-bit address because I need to get to my video card, which is at the physical address of A0000. Or in other words, that is segment A000 with an offset of 0000. But I need to get to that type of an address, and that's beyond 16 bits. So I need to make sure I can work with 32-bit or long pointers here. Now I'll open up this main that I'm working in. And a caveat I put on a lot of these videos, especially around the programming, is I'm not a C++ expert. I'm just kind of hacking my way through it right now, learning more about it. I don't have header files built out. I need to learn how to do that better. But in this main, I do come in and I create an instance of a class that I created called graphics. And I'll jump over to that in a minute. But in that class, then I can do things like call a method I wrote called draw rectangle. So in this case, I'm going to actually use a random generator, and this is inside of this standard lib, if I remember right. So I seed it real quick, and then I go ahead and I randomize, and I come up with a random X position, Y position, color, and size, along with this other thing of whether or not I draw the shape on both frames of my video card or just one frame. But I draw it and I specify here's the XY start, XY end, the color, and not to draw it on both frames. And when it's done with that, I then do swap to the other frame and draw it again. So I'm kind of manually controlling when it swaps frames and draws on the other frame. And as a reminder, on my video card, the output is using one frame while I can control the opposite frame with my 286 code. And I might update the the frame that's under the 286's control, and then once I'm done updating it, I can swap those and then see it on the output. And that's what I'm doing here. Draw a rectangle, swap it, and as soon as I swap it, it's visible. The non-visible frame now can be updated. I don't need to swap it back. It's just now it's ready so that if I do toggle back and forth, you won't see flickering or shapes that only show up on one frame. I'm putting the data on both frames. And I'm going to keep doing this, drawing rectangles until a key is pressed. And so I did, maybe just show you what that looks like. I am making a BIOS call for that. So it's basically BIOS interrupt 16, and it's this function 1, and that's a get keystroke status. So I have BIOS support for that. And that's basically going to just let me then keep checking whether or not I have pressed a key on the keyboard. Once I hit a key, then it kicks me out of this pseudo screensaver. But then the question is, how did I actually get in here and start drawing rectangles? And so if I go into this, I just have a for loop, and I'm basically going to go through the columns and then go through the rows. So columns and rows, it's just a loop within a loop, and that's going to give me an X, a Y, and a color, and not to draw it on both frames, to do a single pixel draw. And so this loop is what's actually building out that rectangle pixel by pixel. Now I've done something like this in previous videos, but inside of this draw pixel, I was calling an interrupt to my BIOS on my 286, which was then writing to my video memory. That's not what I'm doing here. Now when I go to draw pixel, what you're going to see is I'm going to write out to memory directly, and that's going to be done through this procedure here called write word far. But before that, I make sure that the X and Y position is within bounds. I then have to put together the address of that pixel. So I need the physical memory address of the pixel that I want to modify, and every pixel is 2 bytes. So I have a quick formula here that just says, okay, take the X position times bytes per pixel, which is 2. Add to that the Y position times the bytes per row. And for my video card setup, I have 2K of memory per row. And then add that to where the video card memory starts at, which I have set up as this A000:0000. So that, if I think about assembly, is kind of like that is my segment, and my offset is what that's showing me. And really I'm specifying the segment with this, and then the rest of this is going to specify the offset as I add it into it. I have a procedure called set segment. So if I give it a vertical, a Y position, it'll go to my video card and actually change the IO, the register, to the 64K window of memory that I want to modify out of my video card. And so that has to actually then go out and do an IO type of a call. And so I'm using this procedure called outPW, and I'm also using an inPW. So the way this is working is I'm going to read from my video card from IO address, IO port address A0. So that gets me to the video card IO, the register in it. I read it, and from that I look at just the last few bits, which make up the last 4 bits make up the segment, the active segment that I am outputting. I then do a little bit of real quick math just to say, convert this Y vertical position into which segment is it within, and set the video card's current segment to match that. So you can look through this logic here, but all I'm really doing is I'm saying, okay, go give me my current, give me the register, read out the last 4 bits, that tells me the segment. I then look at my Y position, and I look at certain bits within that, and I shift it to the right, and that's going to tell me what my new segment number should be. And if my new segment doesn't match my current segment, then I go ahead and write out to the IO register on the video card whatever that new segment is. So I take the current register, clear out the segment data, and then put in the new segment information and write it out to that IO port on the video card. So that's allowing me to go through a single 64K window in my 1 megabyte address space and get to the full 1 meg of video memory on one of my video card pages. And so then I'm going to go back up here. I set the segment, and then I call this write word far. And so for now, I just made another file over here called rehsd_io, and it's just miscellaneous IO stuff I'm putting in here. But this write word far takes in that pointer that I am pointing to the memory address and the value. And this is just an inline, so it's an inline function, and that is going to look like this. So I'm essentially going to say assign a value to this right here. So take my address, convert it to a uint32, and assign the value. So that, along with that change in how I build, allows me to write to the video card memory. So I do a draw rectangle. The draw rectangle gets me in here. I do a loop to really draw out all my individual pixels. The individual pixels I'm going to write out using this write word far. And so then in this case, if I did say swap frame, it would actually do a swap frame and do the same thing on the other frame. This would be pixel by pixel, and I definitely don't want to swap frames with every pixel. I want to draw a rectangle, then swap the frames and draw another rectangle on the alternate frame. And that way you don't see it drawing pixel by pixel, you'll see it draw rectangle by rectangle. So that's my draw pixel, and I have the draw rectangle. Some of the other things that I have in here, again, I've got this set segment code I showed. I check if it's valid. I have a draw circle that I'll put code into. There's nothing there yet. I do have a clear screen, and for the clear screen, I am making an interrupt call because I already have a pretty efficient process in my BIOS code to clear the screen. So I just call interrupt 10, and it would be function 6, which is a scroll function. But if the AL is a 0, it treats it as a clear. So then I clear the screen. I do have a procedure that is the swap frame. So to swap frames, I am making an interrupt call. And after I do the interrupt call, I wait until vsync has occurred, just so that I don't have an update to video memory, and I swap frames prior to hitting the end of that as far as the actual draw on the video output. So that's all this is doing, is just waiting until I get hit vsync. So those would be the big ones I have so far. I do have something to disable keyboard cursor. I have another one here to set the cursor position. Those are interrupt calls that I'm using for those. And there's this other thing I'm using called set print char options that I use in some of my code. Not real important right now. But that's stuff I started to build out in this graphics class. And then back from this main, I'm simply calling some of that. What I'm going to do next is probably continue and try to add in additional functions in this graphics. So I can come in here and do things like my draw circle, which I haven't put in yet. I already have the logic for that in my assembly, so I'll just move that over to C++. But then I want to do things like draw arcs and polygons and other things. So I'll work on that code next and start getting all of these fundamental concepts down in my video code here, so that I could do something like start to assemble a game or find some existing game source code that I could maybe take advantage of, some Tetris or something like that. But that's all I had for now. Just thought I would show that I am able to get in here. I am able to start accessing the video memory directly and write to that video memory without having to go through a BIOS interrupt routine to update the video RAM with the updated color data, or even to identify and switch which of the 16 different segments of 64K on the video card that I want to work with, or which frame I want to work with. Now, I am using an interrupt for the frame right now. So if I go and look at the swap frame, that is an interrupt call. But all that interrupt call is doing is some IO to the video card that's modifying that register. So I can swap this out from an interrupt BIOS call into a direct IO call, and I'll probably do that here pretty soon. So the goal is to minimize any BIOS interrupt calls and just go straight to the video card register through IO, and go straight to its memory through memory mapped interface in that A000 segment. So I think this is promising. It's showing that I can get to the video card memory, I can modify it, and now I just need to experiment more with this and see what all I can do with it, and see what kind of things I can learn about C++ and start trying to improve my C++ skills. So more to come on the video side of things in a later video.